Okay. So synthetic division, when we do this, we're going to set up this little box thing. We're going to leave space for 2 rows of numbers. So one's going to be right here, one's going to be right here, then I'm going to draw my line. The coefficients of my numerator are going to go up here, so I'm going to go 3, 21, 38, 6. Is this looking familiar? Who remembers what goes in this little box here? Yeah, it has to do with the x plus 4, but it's the 0 of the x plus 4, which would be negative 4. And then we have another little box down here. What's going to end up in this box at the end? The remainder. You guys have seen this. Yeah. So it's kind of a zigzag thing. We kind of go down and then diagonally up. So when we do this, we always add going down. So there's never anything to add in the first one. So this 3 is going to drop down. So we're adding, and then we're going to take that, and we're going to multiply going diagonally back up. And we always multiply by the thing that's in the box here. So we multiply by negative 4, we get negative 12. And then we add going down, and we multiply going up diagonally, and we keep doing that until we get our remainder, and then we're finished. So 21 minus 12 is 9. Times negative 4 is negative 36. Plus 38 is 2. Times negative 4 is negative 8. And the remainder of negative 2. Yeah, way faster than long division. However, this only works if you're dividing by a first degree polynomial. So if you've got an x squared or x to the third power on the bottom, this doesn't work. At least I've never seen a version of it that can work that way. All right, then we got to be competent in actually interpreting that result too. So what does that tell us? That tells us that this original rational expression that we started with can be rewritten as, so I got to write this out. So this is going to be my constant, this will be my linear term, this is going to be my squared term. So 3x squared plus 9x plus 2 with a remainder of negative 2, and that always goes over top of our divisor. All right, and the big idea that I encouraged you to make sure you're thinking about is that these two things, these two expressions are equal to one another. If I were to graph this in y1 and graph this in y2, they're going to perfectly overlap each other. Exact same values in my table. All right, is it back? All right, I'm going to have you guys try this one, but there is one little trick to this one. Go ahead and write it down. And as you're writing it down, see if you can remember what the hitch is on this one. Say again. Yeah, that's it. That's it. So in our numerator, we're missing a term. There's no x squared term. We ran into this with long division, and I told you it's a good idea to put zeros in long division because it makes everything line up nicely and it gets a lot less confusing. It's absolutely necessary in synthetic division. It's not optional. If you fail to put this 0 coefficient in for our x squared term, then you're going to get the wrong result from this. So So I need 8, negative 72, 0, 6, and negative 50. And the box would be a positive 9. Go ahead and work that out, see if we come up with the same result. That's nice. What? 0 times 9 is not 9. How'd I do? Yeah? What do we got to write this time? Here's constant, linear, squared, cubed terms. So we got 8x to the third. I don't need to write these other terms down in my final answer. 8x to the third plus 6 with a remainder of 4 over x minus 9. Is it back? All right, now for something I don't think you have seen before. Any questions on these ones before we do the super fun one? All right, so we're just going to follow the same process, but there's one little wrinkle to these types of problems. The difference between this problem and the last two is the coefficient here. All right, let me get it set up here. Coefficients on the top, it doesn't look like I'm missing anything, so I don't need any zeros up there this time. What do you suppose we're going to put in the box this time? Negative 2/3 is right. Yeah, we would set this equal to 0, we'd solve it, and we would get negative 2/3. Now, don't start doing the math yet, because we need to talk about, this is where this one gets a little bit tricky, because when we put negative 2/3 into this box, when we get our final answer here, we're not actually dividing this expression. We're actually dividing an expression that looks like this. You don't need to write this down, but we're dividing this, which is not the same. Those two things are not equal to each other. However, we can make them equal to each other pretty easily. Would you agree that these two things are not the same? What fraction could I put in front of this whole thing so that when I multiplied, those two things were equal to each other? Do I need to do anything to the top? Top's fine, right? Okay, well, let's multiply that by 1. We don't need to change that. What do I need to multiply the bottom by so that my two denominators are equal to each other? By 3? That would give me 3x, and 3 times 2/3 is 2, right? So that would get us the 3x plus 2 that we need. Okay. So when I do my final result here, I need to multiply the final result by 1/3. Okay, we got to remember to do that. It's always going to be 1 over whatever your denominator is here. So we're going to go through the process and we're going to get some numbers here, but those are not the numbers we're going to use in our final answer. Because we're not technically dividing what they asked us to divide, we're dividing this version of it. Synthetic division won't work with these coefficients, but we can do this division instead and then just adjust our answer at the end so that it matches what we were originally trying to do. Does that make sense? All right, let's do it. You guys know the trick for multiplying whole numbers by fractions, right? Multiply by the numerator, divide by the denominator. In any order that you like. I usually divide first and then multiply. Okay, so we're dropping this 3 down. We're going to multiply it by negative 2 over 3. So divide by 3 and then multiply by negative 2. 3 divided by 3 is 1 times negative 2 is negative 2. That's going to be a 3. This is way too easy. Divide by 3 is 1 times negative 2 is negative 2. That's going to be a 6. Take that 6, divide it by 3. That's 2. Multiply it by negative 2. That's negative 4. And our remainder is 3. Now we don't touch the remainder. The remainder does not get multiplied by 1/3. So that's the result of doing this division. That's not what we wanted to do. We wanted to do this division. So now we need to take that result and adjust it by multiplying it by 1/3. So, that is a really good question. Why would we not multiply the remainder? Let me write down the answer and then think about that for a second. 1x squared plus x plus 2 plus 3 over 3x plus 2. Why would we not multiply the remainder? Thank you. Well, and now you got me second guessing whether we should divide the remainder. No, that's good. This is good. I've never thought about that before, and I'm pretty sure it's right. Well, let's use our test taking strategy. If I wanted to check and make sure that that was the correct answer, we know how we could do that, right? We could punch both of these in. I'm going to just quickly type the original expression into my calculator. I don't know that anybody's ever asked me that before.
Well, it's because you're already divided by the original denominator, right?
How do you mean?
Because you see, the denominator of the remainder isn't the new denominator that we got from turning it into 2 over 3, the original one. So it already basically applies the 1 over 3 rule. Multiplying the bottom by 3.
Because it's multiplying the. I'm still.
Because we haven't divided the remainder.
Okay, it's like.
Yeah, that's another way to say. I think what you're saying. Yeah, the remainder, what's left is what's left over. It's not getting divided. Yeah, that's it. Yeah. Yeah, the remainder is what's left over. It's not, but I think you were kind of saying the same thing. Yep. Yeah. So we don't divide the remainder because the remainder is getting divided over here. All right, that's it. We feeling okay about synthetic division? Do you guys think you need to practice that 1,000 times before what we do on Tuesday? Probably not. You're going to get plenty of practice with it once we get to what we're doing on Tuesday. Question? Yes?
You probably still could divide the 1/3. We just put x plus 2 over 3 under the 3. We divide that by that, and then we apply the times.
Say that again. So if I divided my remainder by 3, it would be like this. So that would be a 1 over what?
Well, no, you multiply by the 1 over 3.
Yeah, 3 times 1/3 is 1. And then what will go on the bottom? So So if I did, you said I could divide this by 3.
No, you divide that by the x plus 2 over 3.
By the x plus 2 over 3. Oh, okay. Oh, yeah. Yeah. Because these two things are the same, aren't they?
Yeah.
This is just, if I multiply that by a fancy version of 1, that's what this would be. Yeah, I like that. Okay, you guys came up with a couple good reasons why not to do that. Okay. Any other questions or thoughts on synthetic division? We're not going to be doing it as much as you did in Algebra 2, because we're going to be using graphs to help us. Our goal on Tuesday, what we're heading towards, and what we're going to kind of move towards today with our activity, is I want to be able to give you on Tuesday a polynomial, a 5th degree or a 6th degree or a 7th degree polynomial, and I want you to be able to factor it. Okay, and these polynomials are going to have, for right now, they're going to have real roots, meaning no complex or imaginary roots. But those roots are could be kind of messy. You could have roots like 2 plus root 3 over 5 could be one of your roots. We're going to do this by building a P over Q list. If that's not sounding familiar to you, it will once we've done it. I know you guys did that last year. Last year you had to hunt through your P over Q list and try a bunch of stuff with synthetic division to see which ones worked. That's kind of our fallback plan, but we're actually going to use our graphing calculator and look at our x-intercepts to give us some hints so that we don't have to hunt through everything. We're still going to need to use our P over Q list, but we're not going to have to hunt through everything. Okay, but we're not doing that today. Today we're gonna stick with what we were doing last class, but in reverse. So last class I was having you graph some polynomials. Today's activity, I'm going to give you the graph of a polynomial and ask you to write an equation. All right. So I'll get you onto the activity here in a moment, but here's the gist of what you're going to do. You're going to look at a graph that'll be on Desmos on your computer screen, and you're going to look for things that are going to help you find the factors in your polynomial. Where are you going to look on your graph to find those factors? How do we see factors on a graph? What do those translate to? Yeah, x-intercepts. X-intercepts are going to give us the factors. So for example, if I had an x-intercept at -6, I'm pretty sure there's not in this first one. If I had an x-intercept here at -6, I knew there would be an x plus 6 here, right? And what's going to help us find the powers on those factors? What are we going to look at our graph to see whether it's a squared or a third power? Yeah, the behavior there, right? Because the behavior, whether it crosses the x-axis or bounces off the x-axis, tells us whether it's an odd or even power, right? And how are we going to tell the difference between like a 1st degree and a 3rd degree? You're not going to have anything higher than a 3rd degree. They're both going to cross. What's the difference? Yeah. So one's like a straight shot through, and the other one kind of does like a little kind of curve thing. A chicane is what they call that in racing. No, that's not a type. That's a racing term. It's like a curve they put in the road to slow people down. Yeah. All right, so that's what we're going to do. There is an activity on Desmos. So if you get your laptops out, go to student.desmos.com. It's going to ask you for a code. I'm going to give you the code. Folks, I did not require a login for this. Don't make me regret that, please. So you can put in a nickname for yourself. Just keep it appropriate, please. Thank you. If you want to give yourself a nickname to be anonymous, that's fine. I am going to be putting people's screens up on the screen here, but I won't be recording that part of it. But if you don't want to have your name up on the screen,